Hey everybody, this is Joe Price. So Terraria 131 was just released, and it is a very exciting update for builders and engineers. I'll be uploading a series of videos over the next several weeks showcasing various electronics builds. And today we're going to start by taking a look at a passcode-protected door that uses one of the new logic gates that were included in the update. So the passcode-protected door requires us to input a sequence of numbers in the correct order in order for the door to open. So the door here is on the far right, and we'll have to actuate it in order for it to open up. And this particular mechanism was designed to accept 5-digit codes, but it can be extended to accept any number of digits. Okay, so let's take a look at what happens when we input just a random sequence of 5 digits. Let's say we input 1, 2, 3, 4, 5. Alright, so nothing happened, the door remains locked. Let's take a look at what happens when we input the correct code, which is 17747. Here we go. The door has opened, became actuated, and we can pass through. There's a reset mechanism here. We can reset at any time, and the reset is also what we pull if we want to close the door again. Alright, so let's talk about how this mechanism was put together. So this mechanism can be divided up into two parts. The part on the left is basically a counter. It counts how many times the levers were pulled. The moment the 5th lever is pulled, it resets the entire system. The portion on the right is basically a tracker. It keeps track of the correct digit inputs, and it opens up the door. It actuates that door at the very end. Now, both of these mechanisms include logic gates. So let's take just a quick moment to talk about the logic gates themselves and how they operate. So the basic setup is as follows. Each logic gate consists of a box and some number of lamps stacked directly above it. You can have just one lamp, you can have as many lamps as you want. So there are 6 basic logic gates that were included in the update, although in most cases you can just stick to one. The way that they are designed is very flexible. And the one that I decided to use was the AND gate. So the way that the AND gate operates is as follows. The lamps that are stacked directly above that box, if they all get turned on, they'll turn on the box as well. And every time the box gets turned on, it'll send a pulse through any wire that's connected to it. Likewise, if a box that's on is turned off, it'll send a pulse as well. So here's a quick demonstration. We have 3 levers that are connected to these lamps. We can bring up the wiring here. So if we just add a torch as our output, let's see what happens. So if we pull one lever, it'll turn on one of the lamps, but the box remains off. Pull the second one, turn on the second lamp, and pull the third one. And once all 3 lamps are turned on, the box gets turned on, and as you saw there, it caused the torch to shut off because a pulse was sent to it. Now, the moment that we shut off any one of these lamps, this box will turn off. It'll also send a pulse and turn the torch back on. Just like that. Alright, so these AND gates are being used in this entire mechanism. Alright, so let's focus on the part on the left and talk about how this counter works. So just bring up the wiring here. Each of these levers is connected through yellow wire, and these yellow wires, they basically pass through the top portion of this mechanism. So we see here that there are 3 rows of these AND logic gates. The top row is just to shut off any lamps that were briefly turned on. The middle row is what keeps count of the number of lever pulls. And the bottom row is basically the reset mechanism. Alright, so let's walk through the actual counter here. So the first time we pull the lever, it'll activate this particular dart trap, and it'll activate this pressure plate. These are special pressure plates that respond to traps. Once that pressure plate is activated, I'll bring up the wiring here again, it will in turn, through the green wire, turn on this particular lamp directly above the box. Now, that won't turn on the box because both lamps need to be turned on. Okay, so when the next lever is pulled, a signal will come through the yellow wire here. It'll activate this topmost lamp, which in turn will activate the box, which in turn will activate the lamp directly below. At that point, both of these lamps will be turned on, activating the box below them. When that box is activated, through the blue wire, it's connected to the dart trap below, and that dart trap will fire. Now, other things are happening at the same time. Okay, so when this topmost box is activated, it'll send a signal to this particular lamp, turning it off. When this lamp turns off, the box turns off. And when the box turns off, it'll turn off the lamp directly below it. Similarly, this box that activated the dart trap, when it turns on, through the blue wire, it'll turn off the lamp directly above it, and that box will turn off as well. So at that point, the signal gets carried to this particular lamp. That lamp will turn on. Yeah, let's actually see this. So just pulling any lever, as you saw, that first dart trap fired, and it turned on that particular lamp. Next time I pull it, that lamp will turn off, or at least the lamp directly above will turn on, activate that dart trap. It'll cause the lamp right here to turn on. Let's take a look. Yeah, just like that. Now, we actually don't care what is happening in this particular column at this stage. All that matters is that we're progressing the signal rightwards. All right, so when we pull the lever again, this lamp will turn on, and if I pull it one more time, this lamp will turn on. Yeah, just like that. And again, we don't care what's happening in the previous columns. So the final pull, the fifth pull, will again activate that particular dart trap, and this time around, the dart trap will activate a pressure plate that is connected through red and yellow wires. Now, the red wire passes through all of these lamps in these logic gates in the bottom row. It'll activate all of them. And any of the lamps that are turned on below will cause the boxes at the very bottom to turn on as well. This is a reset mechanism. So basically, any lamps that are turned on will be turned off by the reset mechanism. Yeah, so let's do that. Pull the lever one more time, and as you can see, everything has shut off here. So this actually illustrates three different mechanisms in one. The top row illustrates how you can immediately shut off anything that you turn on in these logic gates. The bottom mechanism showcases how you can do resets, and the middle portion showcases how you can keep track or keep count of the number of times a lever has been pulled. Okay, so that's the way that works. And again, to bring up the wiring here, that final pressure plate is also connected through yellow wire, and it's connected to the reset mechanism over on the right. So it also resets everything there after the fifth lever pull. So now, the mechanism on the right keeps track of the correct inputs. Okay, so I said that the correct input here is 17747. Let's take a look at why that's the case. So when we pull the one lever, bring up the wiring here, it's connected through red wire, and it's connected to that first dart trap in the sequence. As you can see, the mechanism on the left and the mechanism on the right, they're practically identical. They just serve different purposes. So it'll be the same logic here as far as what happens. Okay, so we pull lever 1, activates the dart trap, and again, it'll light that lamp right above this box in this gate. So next, we need to have a signal coming through here. That'll happen if we pull the 7 lever. Yeah, the 7 lever is also connected to other columns here, but this is the next one that we're interested in. Okay, so once we pull the 7, that lamp that was turned on, it'll basically hop over here. The signal will hop over here, turn on that lamp. Yeah, let's see the progression here. So we pull 1, yeah, turned on that lamp. We pull 7, and there we go. This lamp got turned on. So we're progressing the signal slowly to the right. So the next column is also connected to the 7 lever. Okay, so pulling that, we cause it to jump and then to the next column. Now, the next column is connected to the lever number 4. Okay, there's a little wire splitter, junction splitter here that we are using so that we can crisscross the red wires. All right, so when I pull the lever 4, the signal will jump to this position, like that. And finally, this final column is again connected to the 7 lever. When we pull it, the dart trap that'll be activated will hit this pressure plate, and this particular pressure plate is connected through green wire to the actuators on this door. So it'll actuate that door. Yeah, let's take a look. Just like that. This light, or this lamp, is turned on. This is part of the reset mechanism for that door. Alright, so the reset mechanism, when we pull this lever, it's connected through the yellow wire, which will reset everything in the right side of this mechanism. It's connected also through the red wire. It'll reset anything on the left part of the mechanism. And also the blue wire serves as a reset for the door. Just like that. Alright, so there we have it. So this is how it all operates. And this is just to give you a bit of a taste of what sort of things are possible with these new logic gates. So this is a fairly small build, but I'll be showcasing in future videos much larger, more complex builds. And as always, I'll be providing links in the description box to written guides, so you can take a look at schematics, and this will give you a chance to build one of these mechanisms for yourself on your own world. It's a very good idea to play around with these for yourself, just to get a good sense of how these logic gates operate and how some of the other components operate that were included in the update. This is a really great opportunity with this update to learn a lot about logic gates themselves, but also have quite a bit of fun experimenting with various mechanisms and potentially building some really grand contraptions down the line. Alright guys, so that's it for now, and in the next video I'll be showcasing something a little bit more complex. Alright, so that's it for now. We'll see you in the next video.